Welcome to lesson 15, exponential functions. In this lesson, we're going to define what exponential functions are, learn how to evaluate them, graph them, and determine their equations, and apply them to real-world situations. So let's talk about what an exponential function actually is. So far, all of the equations that we have been dealing with in this class that have exponents in them, because we have dealt with exponents, have had the variable as the base and the exponent was the constant. So what I mean by that is we had like basic quadratic, right? 4x squared or something like that. In this example, the exponent is a constant. It's just a number, and the base is the variable. The x is the base. And we had more, we had some polynomials that had higher powers, etc. But still, in each of those cases, that was still exponent is a constant, the base is the variable. So we're going to flip that around to make exponential equations. So f of x equals a times b to the x is called an exponential function with base b, and b is a constant, so is a. And b is going to be a positive constant, right? So it's positive, not equal to 0, just greater than 0, and not 1. There's a reason why b is not 1, because 1 to any power is just 1, right? And so if b is 1, that acts differently than all of the other functions. It's just a constant. It's actually a horizontal line. So we're going to talk about positive numbers raised to the x, but not 1. Okay, so just a couple of quick examples of what that would look like. A really basic one would be like 2 to the x, or the base could be less than 1, like 1/4 to the x. Those are kind of the most basic, it's just the b to an x. But we do expand upon those, and we would still consider something like -2 times 5 to the 3x. That's technically still considered an exponential function, even though it's a little bit more than just to the x power. And finally, we could even have something like 1 plus 1 over x. Oh, sorry. That was for the next one. That had to do with e. So that is not what I wanted to put in this example. Yeah, so those are all exponential functions. Now, we are going to be working with a constant as when we start working with exponential functions, and that constant is called e. It's a number, just like pi, right? So pi is a number. It's a constant. It's approximately equal to 3.1415, and it goes on forever. So e is another constant, and it is approximately equal to 2.72 if you're going to the nearest hundredth. 2.71828. It also goes on forever. And there is a button on your calculator for E. So probably on your calculator, the button says LN, and then above that, it says e to the x. And so you would have to use like a second or a shift button, and you would hit that and then the LN button on your calculator, and that would allow you to do e to a power. So if you tried that right now and you just did e to the first power, it should give you this decimal here. So just be aware that we are going to start using that number. We'll talk about kind of where it comes from and how we apply it and stuff like that. And yeah, it's just another one of those weird math numbers that is actually a letter, apparently. All right, so let's talk about evaluating exponential functions, right? That means just plugging in numbers and figuring out what they're equal to. So the main thing is for following your order of operations, right? Exponents come before multiplication, and addition and subtraction comes last. So if you were going to evaluate this first function, I'm sorry, I'm looking for my calculator as I attempt to talk at the same time. It's never a good idea to multitask. We are going to try to plug in 4 to the x here and then evaluate this expression. So I have 16.5 times 1.025 to the 2x. So 2 times 4. I'll make that a little bigger so my... So what comes first here is that we would need to raise this number to this power. So, thinking of that as 16.5 times 1.025 to the 8th. And this is what has to come first. You do not want to multiply 16.5 times 1.025. Okay, the exponent has to come first. So you're going to plug that into your calculator. And I want to talk a little bit about rounding errors. You don't want to plug this into your calculator. So let's see, I'm going to go 1.025, and I'm going to raise that to the 8th power. And I have this big long decimal. So obviously I don't keep using the highlighter. It's a common problem for me. 16.5, and I have 1.218402897. I'm just writing this out. It keeps going, but I'm going to leave it there, right? Here's the problem. If I were to take my calculator and go, okay, I'm supposed to, let's say I was supposed to round to the nearest 10th, and I just take this as 1.2 and then multiply it by 16.5, I've rounded too soon. So the best thing that you want to do, and it will cause a rounding error. So the best thing you want to do is not even actually write this number down and do a new calculation. The best thing you want to do is just do this in your calculator and then immediately hit times 16.5. I'm doing that now. And I have 20.103647, right? So let's say I said round to the nearest thousands, 3 decimal places. So 1036 would round to 10.104. And that would be my rounded answer. Now, if I did 16.5 times 1.128 in my calculator, in other words, if I rounded at this step and just used 1.218 times the 16.5, I get 20.097, which is, close, but not the same. And that rounding error could cause you to get it wrong, like if you put it in a homework system. So don't round too soon. Always keep many more digits than you need before the final calculation, and then report. Then round it to whatever place they asked you to. Okay, so let's just keep doing a couple more. I'm supposed to plug 3 into this function. So h of 3 would be, I could have called that f of 4, I suppose. 88 times 0.94. I'm just going to put this in parentheses, to the 1/3. Now we know that 1/3 power is the same as a cube root. So either way, the next thing I'm going to do is I'm going to plug that into my calculator. Again, just logistics. When you're plugging these things into your calculator, if I'm going to plug in 0.94, I need to put my exponent button, whatever that is. Mine looks like that. Then I need parentheses, 1 divided by 3, end parentheses. If I don't put those parentheses, it's not going to give me the right answer, because it's going to think my exponent is just the 1. So in order to tell it that the exponent is the entire 1/3, I have to use the parentheses. So I'm going to do that calculation first. So 0.94 times, to the 0.94 raised to the parentheses 1 divided by 3 power. I hit equals, I get this big long decimal, which again, I could put some of that here. I'm not actually going to generally use that. I'm just going to hit times in a second. 0.79, 5861087 and some change. But I'm not even, it doesn't really matter because I'm just going to go times 88. And that gives me 86.2035, so 204 if I'm going to round to the nearest thousandth. So luckily for us, unlike chemistry, I'm not going to worry about significant figures and all that kind of stuff in this class, but you do need to pay attention to rounding and when to do it. All right, our next one should be pretty straightforward. I have an x equals 2, so the big thing here is I want you to remember, what is the base of this exponent? What does this 2 apply to? It's just the 4. It's not the negative. There would have to be parentheses in order for the 2 to extend to the negative. So this is just negative 16. 4 times 4, then times a negative. All right, and last but not least, we're going to plug in 1 to this function here. So f of 1, oh, we've got an e, is negative 2e to the negative 4 times 1, which is just negative 4, plus 11. So what comes first is e to the negative 4th. So this is your opportunity to find your e button on your calculator. Raise that to the negative 4 power, which again, you might want to put that negative 4 in parentheses just to be sure that it's raising it to that whole power. I got 0.01831563888887, but I'm not going to do anything with that because I'm going to multiply it by negative 2. I'm going to hit enter. And then I'm going to add 11. So I did all those calculations kind of in one step in my calculator, and I ended up with 10.9633. So that would round to 10.963. Right. So evaluating exponential functions is not difficult, but it does take a little attention to detail. So as we are going to spend a lot of time talking about these functions, let's take a moment to discuss what exponential growth really means, because a lot of times you'll hear these terms like, oh, that increased exponentially, or, you know, oh, it changed by this percent every year, which is actually exponential change. And so what does that mean? We're going to kind of just do a little exploration here to get a sense. Again, I'm always trying to help you get some intuition about how the things we're learning now are similar or different from the things we've learned before. So we're just going to make a little chart here. And what we're going to do is I've given us some inputs, and we're going to fill in what's the output for this exponential function, 2 to a power. So 2 to the 0. Anything to the 0 power is 1. 2 to the first, 2 squared, 2 to the third, 2 to the fourth, the fifth, and the sixth. So what you can see has happened is that every single time the x increased, right? The x is just going up by 1, adding 1 each time. What's happening to the y here is it's actually being multiplied by 2, which makes sense because we're adding 1 to the exponent, right? So exponential growth, which is what this represents, is a multiplicative process. It's the amount is doubling, or if it had been 3 to the x, it would have been tripling every single time we tick up by just 1 in our inputs. How is that different from, say, a linear equation that we started with way back in the beginning of the semester? Well, 2 times 0 would give me 0. 2 times 1 would give me 2. 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 2 times 6. So what's happening here is that this is also additive. It's going up by the same amount each time. So the increase is constant, by the way. That's what we called slope, remember? The increase is constant and it's an additive amount. So this kind of growth is much slower. It's just going up by 2 each time. Whereas the doubling means that this amount is going to grow quite fast. So exponential growth refers to the original value from the range increases by the same percentage. This is doubling, which is increasing 200% over equal increments found in the domain. So every time the domain went up by 1, this doubled or increased by 200%. Whereas linear growth refers to the original value from the range increases by the same amount. It's adding to each time with the same increments. So as you can see, that's where we think about, oh gosh, that's growing exponentially. I mean, it's just ballooning really big because every single time it's doubling or tripling, as the case may be.